Hey guys, welcome to another tutorial. In this tutorial, I'll be showing you how to create a grid in your game. So before we get into how to implement it, I just want to show you exactly what it's going to look like when you're finished so that you'll know what to expect. One thing about this solution that's really great is it's extremely optimized. I've seen a couple other solutions that um, they work pretty well, but once you start getting a lot of tiles, like 100 by 100 tiles, it really starts to have an impact on performance. And the great thing about this one is there's next to no impact no matter how big you create the grid. So if you click on the grid, just to show you real quick the things you can customize about it, you can set the number of rows, so 100, so it goes up to 100, number of columns 100, and you can see the FPS right here. It's just going to stay at 120 no matter what I do, even when it's running. You can set the tile size, which is the size of an individual tile, so you can see changing this number makes the tiles smaller or larger. You can change the line thickness, which of course is just the thickness of the lines. We'll set it to something like 10 maybe. And you can set the line color, which of course changes the color of the grid. Maybe make it a little thicker so you can see. So now it's a nice blue color. And if you go ahead and run it, you can see when I highlight over a tile, it highlights in white. And then if I click anywhere in that tile, it will walk me to the middle of the tile. And if I click off of the tile or somewhere else, it just doesn't walk me there. But anyways, that white color that pops up is also fully customizable. So you can click on the tile and the selection color here. So if you want it to be like, I don't know, a yellow color, then when I click on it, it will show as yellow. And you can also change the opacity of the line. So if you want the blue to be, if you want the blue to be, not quite so blue, you can make it a little bit opaque so you can see through it. And you can also do the same thing for the selection color. So if I set it to 1, you'll see it's you can't see through it at all. So yeah, so those are all the different values you can set. And just to show you just how optimized it is, so currently we're at 100 by 100 tiles, which is quite a lot already. As you can see, it goes all the way out to the edge. But yeah, we can go much higher than that with no performance impact at runtime. So I say at runtime because there is a small performance impact if you go to extremely high numbers when you are first launching the game or first loading the game. But after it's loaded and after the game's running, there's no performance impact. So, I mean, you can go up to like 1,000 by 1,000, absolutely no problem. You're probably not even going to see any impact at runtime. You can see it launches right away, and you can see the grid is now, well, you can't even hardly see it if I click on it. But I mean, this thing is, it's ridiculous. It's ridiculous. And you can fully walk and click on any one of those squares, and it will work. No performance impact. But yeah, so you can go up to, I mean, I've gone up to 50,000 by 50,000, and I probably wouldn't go much higher than that just because, yeah, it's kind of ridiculous at that point. But you should never have a reason to go any higher than that. And you can see I'm still at 120 FPS. If I run it, it will take a second for it to like fully create this grid in the game. But then once it's created, as you can see, um, we are totally good to go. We can click on all of these. I think it's 2.5 billion tiles that it creates. Um, so yeah, it's a very optimized solution, and I wanted to share it with you guys because the ones I've seen online are just not optimized at all. So with that being said, we will go ahead and jump right into it. So I'm just going to open up the Epic Game Launcher and launch Unreal. I'm going to use 4.23.1. I have 4.24, except I've been getting a lot of crashes with 4.24, so I'm just not about that life. So I'm going to click on Blueprints, and I'm going to use the top-down blueprint, just because it kind of already has the cursor to world check. And I'm going to call this Grid Tutorial. And we'll go ahead and create the project. And I'm going to move this other one over here to the side, just so I can easily reference it. All right, so as you can see, we already have the functionality if you play it of walking around, but it's just going to wherever you click. There's absolutely no grid involved in this. So we got a good amount of stuff to change here. This is certainly no quick, easy thing and we're done. There's a good amount of math behind this grid. I'll definitely do my best to walk you through and explain it, but if you need a grid for your game, this is definitely the way to go because, like I said, it's extremely optimized, and once you have it implemented, there is basically no performance impact at runtime. So the first thing I'm going to do is I'm going to just delete all this stuff because it's kind of annoying, and I want to be able to have the level set up the same way I did in my little demo that I just showed you. So we'll go ahead and delete all that. Delete all these walls. That didn't work. Delete all these walls. And we want to add a terrain just to make it a little nicer. So we'll click on the landscape tool. And I don't really care about the size. This is probably good. And just go ahead and create, or hit create. All right, so now we got this nice thing. I don't think I started with starter content. No, I didn't. So I can't add grass to it, but that's okay because it doesn't really matter. All right, so one thing that's really important to note about this tutorial, so if you go ahead and you run it and you click, you'll see that he walks to your mouse. And the only reason he's doing that is because there's a nav mesh. So if you go to show and click on navigation, it will show you the nav mesh area. So this green area is the area that he can walk in. If you try to walk outside of this area, it won't let you. And if you click on the little line, if I can, yeah. So this is the nav mesh. So if you move it, you'll see the nav mesh moves. So if your guy isn't walking when you're clicking, then you probably like accidentally deleted this or something. But you can always just add it back on the left here. Just search for navigation. What's it called? Nav mesh bounds volume. Yeah, it's one of these things. Just drag this into the world, and wherever it collides, it will create a nav mesh. So just a little side note there. Okay, so now that we have the world a little bit more simplified, I guess we can jump into creating the grid. So right click and create a new blueprint, and it's going to be an actor. And we will call this BP_grid. So let's see, go ahead and open this up. And like I was saying before, there's no performance really at all at runtime, and that's because 99% of the math happens in the construction script, which is right here at the top. And the construction script runs before, or it runs once when the object is created. And so since we're going to do all the math to figure out how to draw the grid and how to create the grid and all that stuff, it's all going to be done in here. There's really not going to be any performance impact at runtime, which is really, really great. So basically what we're going to do, the magic sauce behind this grid and the reason it can be so optimized is because it's using something called a procedural mesh component. So if you go up here to the top, we want to add a procedural mesh component right here. And basically what this is it allows you to specify triangles that you want to create. So you could like create a box or, like a line in our case, or whatever you want. And you can basically just specify the vertices and the normals and that type of stuff, and it will just draw whatever geometry you give it. So we're going to give it raw vertices to draw our grid, and that's like the fastest thing you can possibly give a computer is just raw vertices to draw something. So that's going to be like the hardest part of it is coming up with these vertices to create this grid, and this procedural mesh component allows us to do that. So we're going to need a few things before we get started. Mostly a good amount of variables that we're going to want to have exposed. So let's go ahead and create those first. So on the left here, click on variables, and we're going to want one for the number of rows. So we'll call it num rows. And I'm going to put this in a section, in a category called constants, because we're going to have a bunch of constants, variables that could be set for our grid. And since it's a constant, we want it to be instance editable, so we can edit it in the editor. We want it to be blueprint read only, since we are the only ones, or we don't want to change this variable after it's been set. And we want it to expose it on spawn, just in case somebody spawns a blueprint through code. And we also want it to be private so that nobody else can access it. So now we have a nice number of columns, and we need this to be an integer as well. And of course, we're going to duplicate this and create one for the number of columns. So we'll call it num columns. And we'll duplicate this one, and make sure you're duplicating, because when you duplicate, it copies all of these things over here that we set. So don't like create a new one each time. Make sure you're duplicating so it copies all this stuff. And we'll call this one the tile size. And again, the tile size is the size of an individual tile. And we want to duplicate another one for the line thickness, which again is just the thickness of the lines themselves. And we want one for the line color, so line color. And this one is going to be a linear color. And duplicate that one. And we want one for the selection color. And again, the selection is the little square that gets drawn whenever you hover over a tile. and duplicate this. We want one for the line opacity, which is just how transparent the line is, and this will be a float. And we want one more for the selection opacity. So yeah, so these are basically all the variables that I was editing at the beginning of the video, and this allows designers or yourself to easily edit all these different values for your grid after it's been created, and you don't have to go and muck with the code or anything like that. Okay, so now that we have all those created, we can kind of start doing some stuff. So, well, actually, we should probably just create a few of these functions first and just knock them out of the way. So let's create some empty functions here that we're going to need later. I kind of like to do this when the tutorial is really large, just so we can get all the functions and all the variables defined up front, so we're not constantly switching back and forth. So the first thing we're going to do is we're going to create the private functions. The private functions are just the functions that are internal to the grid that other people are not going to have access to. So we're going to want one, so click function, and we're going to want one called create line. And yeah, pretty self-explanatory. It's going to be the function that creates one of the lines for our grid, because our grid is actually made up of, if you look at it, it's actually made up just of a bunch of lines. Like this whole line going all the way down to the end. That's one line, and then another line, and another line. We're not drawing individual squares. We're actually drawing the lines, and it just gives the illusion that it's a bunch of squares, right? So that's kind of the idea. So we need a function for creating the lines. So this is what this one will do. And this one's going to take in a good amount of parameters here. So it's going to take in a position for the start. So we want an input vector, and we're going to call it start. And we want another vector, and we're going to call it end. So that's the start and the end of the line. We want one for the thickness of the line that we want to draw. And you might be thinking, why are we passing in thickness? Aren't we going to use this line thickness? Well, we're actually going to use this create line function to also create the selection geometry, that little square that pops up when you hover over a tile. So we need to specify the thickness. If you don't understand why, just you'll figure it out once we start coding it. And then the two other things we want to pass in is the vertices and the triangles. Now, so I guess, yeah, so real quick, create a new parameter, and this needs to be a vector, and it needs to be an array. And you change something to an array by clicking to the right of the variable type and selecting this one that kind of looks like a grid, ironically, and it says array. So we want that, and this is going to be called vertices, and we want one more. And we want it to be an array, but we want it to be an array of integers, so change it to integers, make sure it's still set to an array, and this is our triangles. Now, again, this will make more sense when we start coding it, but just one thing to note here, the vertices and the triangles are just values that are being taken in and modified, so it's not like somebody's passing us the vertices to use. We're actually going to be filling these out, and you can do that because they're an array, so they get passed by reference, kind of. All right, so that's that function. I don't believe we return anything. No, we don't. Okay, so we got our create line function, and again, I said it was going to be private, so click on it, and access specify, we want it to be private so that nobody else can call it, because obviously we don't want other people creating lines on our grid. That'd be kind of weird. And I'm going to put it in a private category. And we want a couple more functions. These ones will be a little simpler. We want one for getting the grid width, so I'll just call it grid width. And we want that to be private as well, and make sure you change it to private. And this one can be pure and const, because it's just going to be returning a value basically, so it's not going to be modifying anything, so pure and const is the way to go. And we can actually just duplicate this one, and we'll call this the grid height, and very similarly it will just get us the grid height. And we want another one for creating, it's going to be called create material instance, and make sure you drag this one up to private and set it to private as well. I'll explain this one a little bit later, but basically this one's just going to create the material that gets applied to the grid itself and lets us, change the color to however we want. Oh yes, so inside this one we need to have a couple parameters. One of them is going to be the color, so change this to a linear color, and make sure you have single variable set, not array. Call it color. And it's also going to take in the opacity. So make another one, we'll call it opacity, and we'll set it to a float, like so. All right, so that's all of our private functions, and then we want to have 3 public functions. So these are functions that other people are going to be able to call to get information out of our grid or to change it in some way. So we'll create a function, and this one's going to be called location to tile. And again, this will all make much more sense once we start implementing them. But what this function is going to do eventually is it's going to take in a location. So we'll give it a parameter for a location. And this is going to be like a world location, like, where your player is or where the mouse is, for example. And it's going to take that location and it's going to convert it into a tile. And in this case, a tile is going to be defined as a row and a column. So the outputs is going to be an integer and another integer, one for the row and one for the tile. So it's going to basically take a world position and tell you which row and which, not tile. It's going to tell you which row and which column that this location is in. And then one other thing we want to return from this function is whether or not that this location is valid. Because if they, for example, in that this one, if I were to click, out here to the left, it's not even on the tile. Or if I were to click, somewhere down here, it's not even on a tile. It's not on the grid. So it's technically an invalid location. So we want to be able to return a Boolean here for if it's valid. So make a Boolean, and I'm actually going to move this to the top with these little arrows on the left, and this will just be is valid or not. So that's what that function will do. That's what that function will do. Super helpful. Another function that we are going to want to have is one that is takes a tile and converts it to a grid location. So we'll go to this tile to grid location, and this one is going to take in a row and a column as well. So create two variables, both integers, one for the row and one for the column. And one more parameter we'll want is a Boolean for center. And again, this will be one of those things that will make more sense when we do it. But basically what this function is doing is it's taking in obviously a row and a column on the grid, and it's going to return to us the center location in world space of that tile, if center is true. If it's not true, it's going to return to us the bottom left corner. So, like, for example, if we pass 0, 0, and we say center is true, it's going to return, kind of where the player is standing. It's going to return right here in the center. It's going to return us this position. But if we don't pass true for center, then it's going to return to us basically where this little ball is at. And we'll need this function for a few things, so it's super helpful. So yeah, like I said, the output parameters that it's going to return is two things. It's going to return, so click plus here, it's going to return to us if it's valid again, because again, it might be, you might pass in -5 for the row, which is not a valid row. So we want to make sure it's valid. And we also want to return the actual grid location. So we'll call it grid location. And this is actually going to be not a vector, it's going to be a vector 2D, because this grid is actually really only in 2D space. So even if, for example, the terrain, you don't have to do this, but I'm just showing you as an example. So even if, oops, that's kind of too much. All right, so even if the terrain was raised right here, and I go ahead and run it, I still have 2.5 billion triangles, so it's going to take a second. So you can see, even if the terrain happens to be above the grid, in this case, that even if I click right here, it's still going to bring me to the center of this tile, because the grid's only in 2D base. It doesn't care about how high the position is. Hopefully that kind of makes sense. So the grid location is going to be in 2D space. So we only want to return a vector 2D. And the last function we want is a function to allow the user to set the selected tile. And that basically is the thing that, allows the user, I gotta really change this down from 50,000 because it takes forever when I click launch. So it's the thing that basically says, draw this little yellow square here. So if the selected tile is 0, 0, then it draws the yellow square there. If it's 1, 1, it draws it there, and so on. I'm going to turn this back down on my project just in case I need to run it again, because 50,000 is kind of ridiculous. It's like, I think it's 2.5 billion individual grids. So, all right, so going back to this, I'm just trying to explain things because I know it's kind of confusing um, if you're just all getting into that once. So set select the tile, the input is going to be 2 integers for the row and the column that you want to be selected. So row and column. And this function doesn't need to return anything. It's just going to do its thing and be done. So yeah, so that's all of our private functions, all of our public functions, and all of our constants. And the only other thing we want to do before we start actually coding things is we want one little handy macro. And this macro, if you create macro, we just want to have one to tell us if a tile is valid. So we will call this tile valid. And this will take in 2 parameters, both of them as integers. And this will be row and column. And we want to have one more input parameter, drag it up to the top, and we'll say it's an execution parameter. And if you name it execute, then it will just default like that. And this will come over like this because we want to continue out of it. And I always rename this one to then so that that's like the default name. So if you rename it to then it like hides the name here because it's the default one, which is kind of nice. And of course, it's just going to return to us another boolean for if it's actually valid or not. So again, this is just a handy little macro we'll write that will take in a row and a column and tell if it's valid or not. All right, so now all of our setup for our grid is done. Obviously, there's no actual grid yet if you go to the viewport because we haven't done it, but we've done a lot of the heavy lifting. We got everything laid out that we need to that we'll need to use for our grid. And I think at that point, I'm just going to go on and end this video and pick it up in the next one. So keep watching. Thanks.